Capacitors store charge. It has been said lots of times already. The charge they store comes from a flow of electrons in a circuit produced by potential difference around that circuit. The circuit provides electrons to the capacitor where they are held in place by a flow of electrons pushing them onto a plate and a gap in the circuit provided by a dielectric, stopping them from moving on to the next plate. Initially, there's plenty of space for these electrons on the plate. The charge builds up quickly. As more and more electrons gather on the plate, however, the force of repulsion between negative charges becomes stronger and stronger. The negative charge on the plate gets bigger and bigger, making it more and more difficult for further electrons to gather on the plate. This build-up of electrons in the plate generates potential. Once this potential is equal but opposite to the potential supplied from the circuit, the electrons stop flowing onto the capacitor plate. This describes the extremes of charging a capacitor, but it doesn't tell us what happens in between. Each new charge on a plate makes it more difficult for another charge to enter the plate. As the charge builds up, it gets more and more difficult. The charge builds up, but the charge build-up slows down exponentially with time. When you remove the external potential difference on the capacitor, the electrons are forced off the plate by the repulsion of like charges. Initially, there are a lot of electrons on the plate, so the force of repulsion is large. As the electrons leave the plate, the repulsive force decreases to zero. Similarly to the charging rate, the discharging rate is also exponential. Charging a capacitor is controlled by the equation Q at a given time is equal to the capacitance of the capacitor times the potential difference applied to the capacitor times by 1 minus the exponential to the power of negative time divided by resistance of the circuit times the capacitance of the circuit. Discharging a capacitor gives the charge as being equal to the initial charge in the capacitor times the exponential to the power of negative time divided by the resistance of the circuit times the capacitance of the circuit. Both charging and discharging are dependent on the resistance of the circuit times the capacitance of the circuit. This number is a constant for given circuits and is called the time constant. If you know the resistance of the circuit and its capacitance, you can multiply them together to get the time constant. If you have a graph of charge against time, the time constant is the time it takes for the capacitor to reach 63% of its maximum charge from zero, or 37% from maximum charge on discharge. This is because this is the value of our charging or discharging equation, where R times C equals 1. The resistance times the capacitance equals unity.